I'm tackling a machine learning problem. I have a dataset of handwritten digits, 0 to 9. Each image has extra information: the writer's ID and whether they used a pen or pencil. I want to use a special technique called StratifiedGroupKFold cross-validation to split the data fairly for testing my machine learning model. This technique helps me ensure that the test sets represent the whole data well. My data consists of images of handwritten digits, ranging from 0 to 9. Along with the image of the digit, I also have information about who wrote the digit and what writing tool they used. This extra information is important for my cross-validation. My goal is to perform cross-validation in a smart way that considers both the type of digit and the writer. I want to make sure each fold, part of my dataset used for testing, maintains a balanced representation of digits and keeps all images from the same writer in the same fold. Based on the way I will be performing this StratifiedGroupKFold cross-validation, I need to determine which statements about this type of cross-validation are correct. This is the main question I will answer by evaluating the truthfulness of the following statements. This statement claims that my special method ensures each fold has the same number of images from each writer. I'll be looking at whether that's true or false. This statement claims that my method is designed to primarily ensure each fold has a similar proportion of each digit, 0 to 9. I'll be evaluating whether this is a primary characteristic of the method. This is the name of a function from the Sklearn library in Python. I use this function to split data for machine learning, making sure that the data is divided fairly and in a way that keeps similar data items together. It helps prevent bias in my machine learning model's performance by carefully managing how the training and testing data are separated. Pretty neat, huh? I'm working with a collection of images. Each image shows a handwritten digit, from 0 to 9. Think of it as a huge database of handwritten numbers. Along with the digit image, I also have information about who wrote the digit and what writing tool they used. For example, I know the writer's ID number and whether they used a pen or a pencil. This extra information is helpful for analyzing my data. I'm using a special technique to divide my data. Stratified means I make sure each subset of data has a similar mix of handwritten digits, 0 to 9. Group means I keep data written by the same person together in the same subset. K-fold means I'm dividing my data into K subsets. I use these subsets to train and test a machine learning model, helping to create a more robust model. It's a powerful way to make my machine learning model perform more reliably. I'm working with a dataset of handwritten digits, from 0 to 9. Each digit is an image. This is the data I'll use for my machine learning project. Along with the digit image, I have some extra information: the ID of the person who wrote the digit and whether they used a pen or a pencil. This metadata will help me in my analysis. StratifiedGroupKFold is a fancy name for a special way of splitting data for testing. It keeps the proportions of each digit, the classes, 0 to 9, about the same across all the different splits. It also respects the grouping of data, writers, keeping all images from the same writer together. That's important for the accuracy of my model. This is the name of a scikit-learn function that I use to split the data to make sure I get a representative subset of my data for my model training. It's designed to keep the proportions of classes, digits, even in each split. Stratified refers to this even class distribution. Group refers to keeping data from the same writer together. And K-fold means I split the data into K parts for cross-validation. Because StratifiedGroupKFold keeps all a writer's images together, if a person only wrote one type of digit, e.g., only wrote 7s, all those images would be in the same split. This is a feature, not a bug. This refers to the problem statement in the context. This is the overall method I'll be using for my machine learning problem. It's a type of cross-validation that involves splitting the data into K-folds, groups, while keeping the proportion of different digits the same across different folds and keeping data from the same writer together. I'm using a dataset of handwritten digits, ranging from 0 to 9. Each digit is represented by an image. This is the data I'll be using for my machine learning project. It's a classic problem. Along with each digit image, I also have extra information, or metadata. This includes the ID of the person who wrote the digit and whether they used a pen or pencil. This additional information is key to applying StratifiedGroupKFold cross-validation. I'll use StratifiedGroupKFold cross-validation. This is a specific type of cross-validation technique where I divide my data into groups and ensure similar proportions of classes, the digits 0 to 9, are in each fold, all while keeping data from the same group, writer's images, together. Think of it like trying to make sure that the folds I get are representative of the entire dataset, and that all the data from a particular writer is contained in one of these folds. I want to outline the process of StratifiedGroupKFold. First, I divide the data into *K folds, paying close attention to keep the proportion of each digit consistent across folds. Second, I ensure that all images from the same writer remain in the same fold. I then repeat the first two steps K times, creating K different training and testing sets. The goal is to have representative data across each fold. I'm using the StratifiedGroupKFold class from the Sklearn library. This tool helps me split data for cross-validation in a smart way, considering both the type of digit and the writer of the digit. It's like having a super-powered data organizer. I have a collection of images of handwritten digits, ranging from 0 to 9. Each image is labeled with its corresponding digit. Think of it like a massive photo album of handwritten numbers. Along with the images, I have extra information, such as the ID of the person who wrote the digit, and whether they used a pen or a pencil. It's like adding extra details to the photo album: who took the picture and what tools they used. This is the technique I'm using to fairly split my data. Stratified means I keep the same ratio of each digit across different data splits, while GroupKFold ensures that all the images from the same writer stay together during the splitting. It's like making sure each team in a game has a fair share of each player type while making sure each team plays together. That way, I get fair results and avoid biasing the model. I'm asking which of the following statements about StratifiedGroupKFold are correct in the context of this data. Think of it as a multiple-choice quiz. This statement is true. StratifiedGroupKFold makes sure that each split has roughly the same proportion of each digit, 0 to 9. It gives priority to maintaining digit balance while also keeping images from the same writer together. This statement is also true. If a writer only wrote one kind of digit, then StratifiedGroupKFold will keep those images together. They might end up in the same split, as it respects the writer's grouping. This is false. StratifiedGroupKFold focuses on keeping the proportions of digits, not necessarily the number of images per writer in each split. This is false. StratifiedGroupKFold is pretty flexible, and it won't raise an error just because you have fewer groups than folds. It will do its best to split the data fairly, even if it means some folds might not be perfectly even. I'm working with a collection of images showing handwritten digits from 0 to 9. Each image is a data point. Along with the digit image, I have information about who wrote it, writer ID, and what they used, a pen or a pencil. I'm using a special technique called StratifiedGroupKFold to fairly test my machine learning model. It helps me split my data into groups while keeping the balance of different digits and ensuring images from the same writer are always in the same group. It means the proportion of each digit, 0 to 9, should be roughly similar in each group I create. For example, if 10% of my data is the digit 3, each fold should have around 10% 3s. This is the overall dataset of handwritten digit images and their associated metadata that I'm working with. This is the specific tool from Sklearn, a popular Python library for machine learning, that I'm using to do the StratifiedGroupKFold cross-validation. It handles both the stratification, keeping digit proportions balanced, and the grouping, keeping data from the same writer together. This tells us that each image in the dataset has information about who wrote it, writer ID, and what they used to write it, pen, pencil. This information is crucial for the grouping aspect of the cross-validation. I'll use this information to make sure images from the same writer stay together in the same group during the cross-validation process. This is the specific type of cross-validation we will use. Stratified means we'll keep a similar balance of each digit, 0 to 9, in each fold. Group means we'll keep all images from the same writer together in a single fold. K-fold simply means that we will split the data into K different folds or groups. This tells you the kind of data that we're working with. The dataset contains pictures of handwritten digits, 0 through 9. Each digit acts as a category or class in our problem. I need to keep the balance of these digits across the different folds during the cross-validation. This is the main question. We will evaluate several statements about how _StratifiedGroupKFold works given the specifics of the dataset. I have to analyze each statement carefully, considering how the stratification and grouping requirements interact. This statement is false. StratifiedGroupKFold is pretty flexible. It will try to create folds while respecting the groups and stratification, but it won't necessarily throw an error if there are fewer groups than folds. It does its best. This statement is true, since _StratifiedGroupKFold keeps images from the same writer together. The grouping aspect. If a writer only wrote one digit, all of that writer's images would have to end up in the same fold. It's a consequence of respecting the grouping constraint. This is true. _StratifiedGroupKFold's main job is to maintain the correct proportions of each digit, 0 to 9, in each fold, while still considering the group structure. This is the stratification part of its name. This statement is false. While _StratifiedGroupKFold keeps images from the same writer together, it doesn't guarantee that each writer will have an equal number of images in every fold. The goal is to maintain the balance of digits, not writers, across the folds. This indicates that the problem involves a dataset, specifically one about handwritten digits. The focus is on how to appropriately prepare and use this data for machine learning tasks, specifically cross-validation. This is just another way to refer to _StratifiedGroupKFold highlighting the key aspects of the method: stratification, grouping, and the use of K-folds. The K in K-fold cross-validation refers to the number of folds or groups into which we will divide our dataset. We'll use the data in each fold in turn for testing and validation while using the remaining data for training.